Hello everyone. Welcome back to All About Java lecture series, a beginner's guide to learning Java programming with me, Apurva Barve. In the previous lesson, we learned about the strengths of Java and some important features which were delivered through significant releases. In lesson 2, we will be becoming familiar with the meaning of OOP and then move on to talk about the core fundamentals of OOP, which are abstraction, encapsulation, polymorphism, and inheritance. Let me tell you that in this lesson, we are going to only understand these concepts. The syntactical implementation of the same will be covered in future lessons. So why wait further? Let's deep dive. Evolution of OOP. Simply put, OOP stands for Object-Oriented Programming. Although the idea of looking at your functional requirements or user domain in terms of objects and classes was conceptualized way back in 1950s at MIT. It was Ivan Sutherland's seminal project, Sketchpad, developed in 1963, which is considered to be the debut of OOP. However, the honor of being the first ever OOP language goes to Simula, which was formalized around 1965. The concepts of classes, inheritance, dynamic binding, which were later used and fine-tuned by other OOP languages, were first successfully implemented in Simula. Around 1967, Alan Kay, the father of OOP, delivered small talk to the development community and officially coined the term OOP. By 1980s, we had OOP languages such as Objective-C, C++, and Eiffel prominently used in the market. By 1990s, OOP had become the popular way of programming, and it is around this time when Java was introduced, and till date it is considered to be one of the most pure OOP languages in the market. So, what lies at the crux of OOP? As you know, OOP stands for Object-Oriented Programming. So any OOP language revolves around objects. Everything is object. Objects have data. Simply put, data are the attributes and they have behavior. Behavior means methods. In order to get anything done in an OOP language, you have to use the relevant object and call the necessary method on that object. To do so, the typical syntax which we follow is object name, dot operator, method name. This syntax should pretty much get you around any OOP language. As we go further ahead into the lecture series, we will be able to design our own classes, create their objects, write methods into the classes, and use the whole functionality effectively in the right spirit of OOP. Now let us try to understand the core features of OOP. To begin with, let us talk about abstraction. Consider a student. This student has many attributes such as name, age, favorite color, best friend, address, hair color, pet's name, favorite sportsman, contact number, to list a few. If we look at this object, student, from academics domain point of view, we soon realize that the attributes such as name, age, address, and contact number are relevant to the domain, while the others such as favorite color, best friend, hair color, pet's name, favorite sportsman are irrelevant. So it is better to ignore or forget these irrelevant attributes and focus or continue only with the relevant ones. This form of data filtration is called as data abstraction, wherein we choose to continue with the relevant data or attributes and let go of the irrelevant data or attributes. Makes sense, right? Let's continue further. Now let us consider an ATM machine. This machine does a variety of things such as accept PIN, verify PIN, display transaction options, print receipt, save transaction record, update account balance. Some of these features are delivered by the hardware of the machine, while some are delivered by the software which is installed on this machine. Some functions are executed on the backend side, while some are executed on the machine side. No matter which function is getting executed, the user of the machine has no clue about the nitty-gritties needed to complete that function. Also, we design the functions in a way that they are in line with the ATM machine, and we do not incorporate any other over and above functions, processes, or methods. This type of abstraction is called as process abstraction, wherein the user is allowed to focus or access only the relevant functionality without having to bother about the complexities which are involved in delivering that functionality to the user. So, let us quickly recap what is abstraction all about. Abstraction allows us to focus on the essential qualities. It lets us discard unnecessary or irrelevant items. We target the what. What is relevant? What should be continued? What should be considered? Data abstraction and process abstraction are the two ways in which the fundamental of abstraction is exercised. Abstraction is practiced at design level when you are thinking or when you're deciding what the classes should be and how those classes should behave and what data should those classes retain within them. Abstraction promotes maintainability and it reduces complexity. In Java, we use abstract class and interface to achieve abstraction. Fair enough, isn't it? Let's move on. The next OOP concept that we should be talking about is encapsulation. Encapsulation, as the name suggests, is all about packaging things the right way to promote usability and lessen the complexity. Let us understand this with an example. Once again, let us focus on the ATM machine. This machine has numerous attributes such as PIN, account number, amount, balance, and it displays some behavior or it allows some methods such as validate PIN, performing banking operations, update balance. Now, when we consider ATM machine as a class, then PIN, account number, amount, and balance become the data, the attributes of the class. And validate PIN, perform banking operations, update balance become the behavior, the methods that are given by the class. This is encapsulation, where you put a protective wrapper around your data and behavior and present them as a single unit. Here, the single unit is ATM machine. So, let us quickly recap what is encapsulation. Encapsulation is all about binding your code, that is the behavior, and data together in a single unit. Here, our unit is a class. Wrapping the components together to keep them safe from misuse and manipulation. Naturally, because the class is responsible for the data as well as the behavior, the methods, and it is accessed through objects, they are safe and they are not misused. Encapsulation gives you a well-defined interface which controls the access to the code and to the data within the wrapper. In Java, encapsulation is implemented first at the class level, the moment you create a class, and within the class, it is implemented by using private access modifier for the instance variables and giving public getter setter methods for the same instance variables. When we do encapsulation syntactically, we will explore this in further detail. Till then, it's time to talk about the next feature of OOP, and that is polymorphism. Let us say there is a lady called Miss Jane. When Miss Jane is with her family, she is their mummy. When she is with her friends, she is Janie. When she is with her patients, she is Dr. Jane. So here, one person has multiple roles depending on the audience present in front of that person. Similarly, OOP allows one interface that can have multiple behaviors or methods or functionalities to achieve different functions. Which behavior will be invoked when depends on the target audience or the target specification. This facility of having multiple forms of a given interface or a method is called as polymorphism. Let us take one more example. Consider the infotainment system in recent cars. Based on the type of our phone, this system demonstrates specific functionality while keeping the interface same. So if Android phone users use this interface, they will get access to the methods designed for Android systems, while iPhone users access features designed for Apple systems through the common interface. This is what polymorphism means. Poly means many and morph means forms. So let's do a quick recap. Polymorphism is one feature delivering different functionality depending upon the situation. One interface having multiple methods and each method invoking a separate functionality. It is the job of the compiler to select specific functionality based on the situation. So everything rests on the compiler here. Java allows two types of polymorphism. The first one is static polymorphism, which is also called as method overloading. And the other one is dynamic polymorphism, which is called as method overriding. Again, these two concepts will be explored in further details when we do syntactical examples of polymorphism. Let us go ahead and talk about the last but very important feature of OOP, and that is inheritance. To understand this concept, let us discuss games. When I say games, we could be having indoor games, and within indoor games, we could be having board games or card games. Or we could be talking about outdoor games wherein we have team games or individual games. Here in front of us is a hierarchy, a tree-like structure of different games. This is exactly what inheritance looks like. Here, as we go deeper into the hierarchy, the categories become more and more specific. And as we climb up higher, the categories become broader. Let every category be considered a class. The class which is above is a superclass, while the class which is below is the subclass. Superclass is also called as a parent class, and subclass is referred to as the child class. The parent and child need to have is a relationship. The child is a type of parent. So, indoor games is a type of games. Team games is a type of outdoor games, which in turn is a type of games. Let's talk more about the hierarchy to understand inheritance better. Let us consider a broader class, animal. Animal class has attributes such as age, weight, gender, to name a few. And it shows some functions such as eat, sleep, sound. We write one more class, mammal. Now, mammal is an animal, but it comes with its own attributes, which are gestation period, mammary glands, and it has its own method, which is give birth. But because mammal satisfies is a relationship, and we see a scope for linking mammal to the broader class animal via inheritance, mammal class inherits the properties and behavior of its superclass, which is animal. And now it looks like this with age, weight, gender coming in from the animal class and eat, sleep, sound also coming in from animal class. This happens because of inheritance. Let's consider one more class, a third class, which is dog. Now, dog class has its own attributes like tail length and breed. And it has its own methods, wag tail and get trained. Again, dog is a mammal, which in turn is an animal. So, dog class stands to inherit from the mammal class as its superclass, immediate superclass, and from the animal class as its super class. And now finally, when dog joins the hierarchy of classes here through inheritance, this is how the dog class object looks like. So as you can see, by creating a hierarchy of classes here, we are promoting reuse of attributes and methods. And this is exactly what inheritance aims at. One thing that you should understand about inheritance is that in inheritance, as we go into the hierarchy, the classes begin to get more and more specific. For example, the dog class has attributes and methods only pertaining to the dog behavior, to the dog class. This is specific lower class, a child class. If we go higher, let's take animal class. It has got attributes and methods which belong to a broader category of animals. This higher level class is the superclass or parent class. So, what is inheritance all about? Well, inheritance is about creating hierarchy of related classes. It is very, very important when you design classes and when you think of relating or connecting them in inheritance. It is very, very important that you pay attention to the related factor between the classes. So, the classes have to have is a relationship with each other. General or higher level class is the superclass or parent class. Specific or lower level class is the subclass or the child class. Again, inheritance promotes reusability. And in Java, inheritance is achieved through extends and implements keyword. Well, with this, we come to the end of lesson number 2 in All About Java lecture series. In our next lesson, we shall continue to learn about the language, and we will even write our first Java program and break it down to understand what does a program do, how it should be written, and how it is structured. So stay tuned and thank you for watching. Also, check out our videos on Eclipse and JDK installations, the links of which will be shared soon. Finally, do not forget to like, share, and subscribe to this channel for regular updates and to keep learning. Thank you.